Warning, this project contains high voltage. I take no responsibility if you go bang.
Welcome to FuzzyTek, the show where I talk about technical, geeky, nerdy stuff. I'm Fuzzy Manners, and in today's show, I want to talk about what's happening with the channel and introduce a new project I've been working on and talk about some of the older ones. First off, I'm going to start with saying that for various reasons, there are some projects that are no longer going to be completed, or at least they're not on the top of the pile for the time being. One of those is the DJ MIDI controller project. The reason behind this mainly comes down to sourcing parts. Where I live, it's now hard to get parts from eBay, Banggood, AliExpress, etc. without having to pay insane import taxes on anything that comes from outside of Europe. Which also means, unless I really need one, and it's worth the extra cost, no more custom PCBs for me. This is also the reason for lack of episodes, lack of motivation due to the parts problem. Anyway, now that's said and done, I can say the Nixie Clock project is still a thing that will be featured at some point in the future. I also plan on making a video about how to use Arduinos with native USB MIDI and an IBM Model M keyboard bolt modding video, so watch out for those episodes coming sometime soon. On today's episode, I'll be taking a look at my 7-channel neon tube bar graph audio equalizer. This uses an Arduino Nano as the brains and an MSG EQ7 IC to separate the incoming audio into the 7 channels to display on the tubes. I'll talk more about the chips later. Let's start with the meat and potatoes of the project. The tubes themselves are IN9 sealed glass tubes filled with neon gas, made in Soviet-era Russia. The ones I have are dated as being manufactured in mid-1984. They work in a similar way as the Nixie tubes with the numbers inside, which I explained in a previous episode, but I'll briefly explain it again as they're a little different. On the IN9 tubes there are 2 legs, one for the anode, positive, and one for the cathode, negative. A voltage of around 140 to 150 volts DC is applied to the positive leg, which is the outer leg that connects to the metal casing on the inside of the glass, and then the ground is connected to the other leg which runs up the middle of the tube. The clever part is how the tube lights up. It's like a bar graph, so it goes from the bottom to the top, and how much it lights depends on the current. Now, you wouldn't want to go connecting the tube leg straight to an Arduino pin, as that could cause all sorts of dangerous fiery problems, as the Arduino doesn't really like 150 volts drained into it. The best way of connecting these up is using a transistor, more specifically the MJE340. Here's an example of controlling a tube with said transistor and a potentiometer. This here schematic is our test circuit. We have 140 volts connected to the positive leg of the tube, and the collector pin of the transistor connected to the negative leg. The emitter pin of the transistor is connected to ground through a resistor. The base pin of the transistor is connected to the output of a 10k ohm potentiometer, with its other 2 pins going to 5 volts from the Arduino and ground respectively. As we're using an Arduino for this, I'll be using a Leonardo for this example, just because that's what I have to hand. The grounds in this diagram will all connect to the Arduino ground. Now when I turn on the power and move the potentiometer, electronic magic happens. It's using this principle that I'll take the data from the MSG EQ7 via the Arduino and replace the potentiometer. There is a caveat though, and that is that I need to use the Arduino PWM pins to connect to the transistors instead of potentiometers. What's a PWM? And why is that a caveat, you may ask? Well, I'll briefly explain. PWM stands for pulse width modulation, and it's basically a way to get an analog-like signal from a digital one by creating a square wave of on and off at a set frequency. I can't really explain it too well, and I don't claim to know everything about how it works, but that's basically it. You can dim LEDs and control motors using PWM. On the Arduino we can use analog write pin number 0 to 255, with the number being how often the PWM signal is on, known as the duty cycle. 255 is on all the time, and 0 is off. But using PWM is still a digital signal, so what will happen in our case is that MSG EQ7 will say, "Hey you, Arduino, the frequency of the first tube is about halfway, make it so." And the Arduino will say, "Alright mate, no worries," and send out a 127 PWM signal to the transistor. This is what we want to happen, except that the tube will just light all the way to the top but at half brightness. Which is fine for normal LEDs, but not for this application, as the tubes need an analog signal and not a digital one. To change this, I need to create what's called a resistor capacitor filter, or RC filter for short. It sounds more complicated than it is, and as the name might suggest, it consists of just one resistor and one capacitor. The values of the components vary depending on the needs of the project, but in my case I'll be using these little adjustable trimmers in place of the resistor. The resistor connects to the PWM output of the Arduino. The other end connects to the input of the transistor, where we previously had the PWM pin connected to. Also, on this side of the resistor is the capacitor, which goes from here to ground, and that's it. The simple RC filter converts our digital PWM signal into an analog voltage representation. So instead of 5 volts with a varying duty cycle at whatever frequency, we get 0 to 5 volts, just like we did with the potentiometer in the test example. With this information, I can now create an RC filter for each of the 7 tubes. But first, let's rewind a bit. For each of the 7 tubes. But first, let's take a look at what I've done so far. I have this antique wooden box for the project. This piece I'll glue back on once the project is nearly done. It fell off. Anyway, I've drilled holes for various components. Power input, power LED, audio input and output, and a power switch, as well as 7 holes on the top for the tubes. There are also these 2 little holes either end of the top of the box, which I plan to use for some decoration once everything is put together. On the inside, it looks like a bit of a mess, but to be honest, it could be worse, and nobody's really going to see the inside anyway, unless they ask me how it works. I'll start at the power input and work my way around explaining what everything does. So the power comes in here, 12 volts of power to be more specific. The live goes around here and connects to the power switch. The other side of the switch connects to this connecting block, ready to provide 12 volts of goodness to whatever needs it. Which brings me nicely onto the 5 volt voltage regulator, which turns those 12 volts into 5 to power the Arduino, the MSG EQ7 and the power LED on the back. Also connected to the 12 volt block is the high voltage transformer for the tubes, but I'll get to that in a moment. The Arduino connects to the MSG EQ7 and the transistors for the tubes through the RC filters which I was talking about earlier, which I have not yet made. The ground from the power input connects to some blocks that basically take all the ground cables from everything else and connect them all together. The only other sockets on the bottom of the box are the audio input and output sockets. These are tucked away in the corner near the power switch. They're connected together so that it can be used as an audio input and an output while splicing off into the MSG EQ7 via some resistors. One last thing to notice is at the front there is a neon bulb. This lights up when there is power and indicates that the high voltage is live, although the high voltage stays live for a lot longer than when the bulb is lit up once it's been turned off. I'll show you this in a moment. On the top side, there's a bus of connecting blocks at the top. These are all live at approximately 140 volts and supply the tubes. Below it, we have the bank of transistors that connect to the Arduino in each tube. Finally, next to that is the high voltage converter that takes the 12 volts input and converts it to around 140 volts for the tubes and the neon indicator lamp at the front. With this information, I can now create an RC filter for each of the 7 tubes. So, as I was saying earlier, the voltage doesn't cut off instantly when the switch is turned off. In fact, it stays at a dangerous level for quite a bit afterwards. If we say that 30 volts is a safe level, which I'm by no means saying, this is just for the test, we can see how long it takes to get to 30 volts and then down to 0 after being switched off. With the multimeter hooked up to the high voltage side of the project, I'll now switch it off and time how long it takes to get to 30 volts, and then from there to 0. So to get to 30 volts took a total of 11 seconds. To get down to 0 from 30 was a whopping 47 seconds. That's an extra 36 on top of the time it took to get down to 30. My point here is, well, there isn't really one. I just wanted to measure the time it took to discharge. But I guess be careful with high voltage converters in this kind of project, or any other high voltage project for that matter. Don't get zapped up. That's about as far as I can go with this episode, as I actually broke my MSG EQ7 twice. Well, I think one of them was a dud perhaps, but this one no longer works. Not entirely sure why. I probably fried it at some point, but until I can get another one, then apart from finding a way to fix the tubes in place, there's not really much else I can do with this project right now. So on that note, if you have any questions or comments, please leave them below. If you like this video, then give it a like. If you didn't, please tell me why. Please consider subscribing and pressing the bell. You can follow all things FuzzyTek over on Instagram at instagram.com/FuzzyTek show and visit the website at fuzzytek.ml. Many thanks for watching, and until next time, bye bye. Or at least they're not on the top of the pile for the time being. One of those is the Fuzzytron 3000 DJ MIDI controller. Sounds so stupid. Fuzzytron 3000. Or at least they're not on the top of the pile for the time being. One of those, I can't do it. Every time I get to Fuzzytron 3000, I can't say it. Why am I doing this like Gordon Ramsay? Technical, geeky, nerdy stuff. This is scrolling way too fast, I can't see it. Welcome to FuzzyTek. Without having to pay insane import taxes. Import tax? Who the f says import taxes like that? You can follow all things FuzzyTek over on and please consider pressing the bell, but subscribe first because you can't press the bell before you subscribe. And consider subscribing and, you know, press the bell and all that rubbish. You can why have I said all that rubbish? Right, I think that's it. Bye. Bye.